Data set 2, we're just using this formula, 1/2 mr squared. So that's the moment of inertia of a disk. Let me draw a disk. This is kind of what the wheel is like. So this is the radius. And the axle is a weird disk, but we can treat it as a disk too. It's a very tall disk, and this is the radius right here. So 1/2 mr squared for one of the front wheels is 1/2 times 0.08 kilograms times 0.09 squared. And that comes out to this, and the units are kilograms meters squared. Kilograms times meters squared. For the axle, same thing. The mass, though, is 0.36, and the radius is 0.004. So that's this, and it's kilograms meters squared. And then for the total moment of inertia of two wheels and an axle put together, you've got to add this wheel plus that wheel. So two of these plus this. And that comes out to, in this case, this much. 2 times this plus that. Again, kilograms meters squared. Data set 3. So with this, we did two things. So first, you wind your wheels up like this. Wind them up, and as you do that, the band stretches. And you record how many times you wind them up, because when you let your car go, they're going to unwind that many times. And if we know the wheel radius and we know how many times they unwind, we're going to be able to calculate how far your car is going to go while it's accelerating. That's this last part down at the bottom. But the other thing we do is we hang this off the table and just let it rip. So you wind it this way, and then you let it go, and it spins this way, faster and faster and faster until it gets to some maximum, maximum velocity. And to figure out the maximum velocity, we put some sort of a mark on there. So let's say like this. And we see how long it takes for that mark to go around. And we measure that time with video frames. So the slow motion video is taking a video of this, and it takes 240 frames per second. It might take a picture here, and then here, and then here, and then here, and then here, until it gets back to there. So the data show that the number of frames was 15. So this took 15 video frames to get around. First question is, how many seconds did that take? So 15 frames times 1 second per 240 frames, that cancels out the frames. We get the number of seconds. One frame is 1 240th. So basically this is just 15 240ths of a second. What was their angular velocity at that time? So what they were doing, based on this information, this is the time for one wheel rotation to occur. So it's rotating one full time in this much time. And one rotation is 2 pi radians. So I'm really just using this formula for angular velocity. Change in angular position or angular displacement. One rotation, here I'm converting it to radians. One rotation is 2 pi radians. Divided by the time, you get 100.5 radians per second. The energy output, so the bands, since we're not letting the car roll, we're just letting them accelerate this wheel. This kinetic energy that it has is representative of how much energy the bands put out. And the kinetic energy of a spinning object is 1/2 times its moment of inertia times the angular speed squared. So I'm just plugging those things in. 1/2 times this. So where did moment of inertia come from? That comes from number 11, because we're doing the drive wheels and axle. Those are the ones that are spinning. So it's this number. And then the angular speed is the one we just calculated, and that should be squared, so that comes out to 7.784 joules. What's the distance the car is accelerating? So there's this way. So arc length equals theta times r. The car is going to unroll 8 rotations. That is 8 times 2 pi radians. So this is theta. This is how many radians it rotates through. And the radius of the wheel is 0.14 meters. Another way to think of this is find the circumference of the wheel, which is 2 pi r, and then multiply that by the number of rotations, because every time it rotates once, it's going to roll a distance equal to its circumference, whatever that is. Pi times the radius, or pi times the diameter, sorry. So there's the answer. That should be in meters.